So at the business logic layer now, we can start attacking this. We now have the details of the business logic layer, and we can start attacking the developer's implementation. We've attacked Sun's implementation lower down, the skeleton layer, and now we've attacked the business logic layer. We've worked our way through the RMI architecture. Again, you can see actually the last method I invocated as we were kind of profiling it. We passed in 20, the big decimal. We passed in a string saying hello Owasp, and we passed in a vector, and you can see how the vector is actually dumped to the console. And at this point, you kind of realize that with your Java RMI service, if you're not careful about the logging and the detail of actually looking who's invocating your RMI service, we actually see there was nothing, no detail was even given to us until I successfully determined your method prototypes. And then because it's just the debugging information that the developers put in, it's actually come to the console. So the chances are you haven't even noticed that an attacker's just profiled your whole server and he starts actually developing his own customized client. And there we go, we've worked through step 1, 2, 3, and 4, and look at the amount of information we retrieved from 0-day knowledge. And then step 5 is the ability to actually create your own stub. This is where you become creative as a developer, as an attacker. This is where you actually say, well, okay, I know which methods they've implemented. What data am I going to fire over to try and start really pinpointing what the business logic layer is about? And you can obviously look at stack traces and try and rely on the common coding mistakes that occur at business logic layer, and we can determine a lot more detail. As I said, you can retrieve method names, you can retrieve implementations. So for example, you're trying to force stack traces being thrown back to you as an attacker from the server. For example, imagine trying to invocate a number format exception or division by 0 exception. And when you get a stack trace back in Java, for those of you who actually do any development, realize how much detail is given back in a stack trace. You can go through and look how many lines of code have kind of been implemented, look at certain classes, implementation, where the control flow is. So you've kind of done the hard work now. You've actually assessed the whole RMI service. Now it's time to get kind of really creative and develop your own client. 5 minutes, okay. So why is RMI insecure? How has it been possible to retrieve all this implementation, all these kind of details about an RMI service? Well, it's because of the skeleton, this layer that resides on the server side, and you're actually building your business logic layer on top of this flawed skeleton. You kind of really need to understand about the Owasp top 10. You know, the Owasp top 10 doesn't just apply to web applications. Some of the features in the Owasp top 10 do apply to applications in general. And the skeleton leaks vast amounts of detail, and if the developer follows any of those kind of same coding mistakes, you're going to be able to retrieve so much more detail. And it's also the whole concept of RMI, this idea that, hey, there's a client, there's an object, and there's your magic, it talks. This false sense of security causes big problems because the developer doesn't know what happens. He doesn't need to check the lower layers. He's only concerned with his business object. So it kind of really does create this false sense of security that Sun have taken care of everything you're developing on top of their layers, but the layers are flawed. And it's also with the key and the insufficient key space. As I said, it's a 64-bit signed key, but it's not actually a 64-bit key space. So it does not have 18 trillion combinations. And as we've seen, we actually brute forced the key, and I kind of cheated. But it doesn't take long to actually go through several thousand keys a second, 10, 20,000 keys, especially in today's computing resources. And as during the demonstration, the chances are you won't know an attacker's actually profiled your service unless you actually go about doing certain security features that I'm going to quickly go over. So how do you secure an RMI service? Well, there's a couple of recommendations I have for you. Look at the skeleton code. Look at what's actually happening at your lower layers. It's not magic. If you understand Java, if you can read Java, quickly understand about the skeleton and the stub and the relationship. And modify your method hashes. The key space is insufficient. Make it unfeasible for an attacker to actually retrieve the key. You wouldn't actually have a session ID on a web application that was 64-bit, so why have a static 64-bit for an RMI service? And again, make sure your authentication and authorization is implemented correctly, just as you would with your web applications. So something like the Java authentication and authorization service, it's an API that's going to help you implement your authentication and authorization mechanisms correctly, because don't assume that just because you're hosting services that the corresponding stub you give out is just what the clients can see. We can see that if you develop just a couple of methods on your server and you gave a client out and says, hey, you just have access to one method, it would be trivial for us to assume the rest of the functionality and determine it and start developing our client to get all the functionality on the server. And think about your RMI architecture. Don't just expose an object directly. This is what you'll see on a lot of the tutorials. In fact, I've seen it for every implementation I've assessed myself. The object's just hosted, very much like you'll find in WebSphere and JBoss. The Java Remote Management Console is an RMI service, and this functionality is just it's actually released just directly. Think about using a proxy. Don't just allow people to retrieve your reference names for your objects. Your client should have to go through a proxy. They need to authenticate. Then you start passing the details and start checking out what your clients are doing. And again, don't just think about this it's secure because it's magic. Look at the layers, think what's going on, even have a look at the packet traces. I spent a lot of time going over the packet traces to see what was actually happening on Sun's stream-based connection. So start thinking about it in a bit more detail, dig down in this RMI architecture, don't just assume that everything's going to be okay. And enable logging. As I shown during the demonstration of the attack, there wasn't actually any evidence that an attack was taking place, but I'm going to quickly show you what happens if we implement some logging on an RMI service. And unfortunately, not many people do this when they're hosting their RMI service. I'm just going to take down the RMI service. I'm going to start it back up. But this time I'm going to enable logging, which is actually a Java environment variable for RMI services. Okay. So the service is running, and we can already see there's some kind of details. It's going to give us fine debug details. And I'm going to quickly run across the brute force attack, and you're going to see now how things change at the server. So anyone looking at the log files, anyone managing the RMI service will automatically see that an attack is happening. So let's run the brute force attack again, and look at all this detail that's actually happening at the RMI service. You see stack traces and stack traces. It automatically tells you someone is running an attack. They're trying to profile the RMI service. So with logging enabled, you're going to have a greater chance of detecting someone is profiling your RMI service before they've actually developed their client and understood your functionality. So you've seen that RMI spy is actually kind of tedious, requires some code changes, you need to understand Java, you need to recompile some stuff on the fly. But I'm going to make it fully automated. I'm going to take all five steps of the methodology. It's going to be a single click and run. For those people who love GUI, sure, I'll put a button on it. And there's going to be automated interfaces, stub creations. You're going to have packet sniffers. I'm implementing this in Java at the moment. It's going to be reading the packets off the wire. It's going to be looking for the 64-bit key secret. It's going to be pulling off objects. It's going to be looking at what the other clients are, what the implication is actually happening, the conversation between the client and the server, what objects are they sending across, what values are they sending, what's the response from the server. And it's going to pull these objects off the wire, and it's also going to modify them on the fly. So if a client sends strings through or hash tables or vectors, the RMI spy is going to look for these details, going to modify them on the fly, and it's going to replace some of the client conversation, this legitimate client conversation. It's going to run a lot of attacks. Obviously, you need to set up your man-in-the-middle attack.